Hi, this is the second part of lesson 1.7 in geometry, and we're going to be talking about how to use the distance formula to find the lengths of segments. Now, before we get into that, I want to go over something here with you. It's a little bit hard to see this blue line, but if you have a segment that goes from 2 to 3, and if it's a horizontal segment, and I say, how long is that segment? Well, the length is 1, because it goes from 2 to 3, so it's 1 unit. And when we're talking about a vertical segment, so if we go from from 1 up to 2, like this, again, that is 1 unit. So if you have a horizontal segment or a vertical segment, we can just count the number of units. However, if we go diagonally across, my question for you is, how many units is that? Well, a lot of students will look at it and say, oh, that's 1 unit. But technically, it is not. This is 1 unit, and this is 1 unit. And if I were to measure, if I took a string and measured from here to here, and if I took a string, that same string, this would be longer. So let's look at what we have going on here. This is a right angle. Now, if you remember back to 8th grade, you spent a lot of time talking about the Pythagorean theorem, which is c squared is equal to a squared plus b squared. This is the Pythagorean theorem, works with a right triangle. The c is always the hypotenuse, which is this side across from the right angle. So I'm just going to call this c. So let's put the numbers in. So a or b, doesn't matter which is which, they're both 1. So 1 squared plus 1 squared. So 1 squared is 1. All right, and we'll keep simplifying. And so to find the length of c, c is equal to the square root of 2, which I believe is 1.4. Let me do a double check really fast so I don't tell you the wrong answer there. To turn my little calculator over here. Square root 1.4, yes. So as you can see, it's just a little bit longer than each of the legs of that triangle. So we are going to use that in this next problem. It says the distance between 2 points, A, which is at x sub 1, x sub 2, we go over x sub 1 up to y sub 1, and go over x sub 2 up to y sub 2. Let me write those points in, or coordinates, I should say. Okay, so to find the length here, what we basically are going to do is we're going to measure from here to here. And so this distance along here is x2 minus x1. So to figure out what the rise is, we go from here to here, which is y sub 2 minus y sub 1. I'm just showing you how this is developed. Don't worry, you're never going to have to do this on a test, but just so you understand where we come up with the distance formula to find this length. So this forms a right triangle. So using the Pythagorean theorem, okay, so we don't know the length. Well, this is D, so I'm going to write D instead of C. So this side is called D. And A, the side for this side of the triangle, is x2 minus x sub 1 is what I should say, and that's squared. And then this side is y sub 2 minus y sub 1, and that's squared. So to find out what d is equal to, see this says d squared, we'll take the square root of this side, and if you take the square root of this side, you take the square root of that entire side. So d then, the square root of d squared is just a d, is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And this is called the distance formula, and it is an important one. It's one that you're going to want to memorize, and we're going to use it enough that you will. Basically, what we're doing here is we're subtracting the x values, and then you square that answer. And you subtract the y values and square that answer, and you add those numbers together, and then you take the square root. So let's look at how that works. So here it says, Find the length of the segment. Well, the length of the segment would be the distance from point C to point D, so we use the distance formula. And I would like you to write this on all of your assignments because that's a great way to learn it. So we're going to subtract the x's, x sub 2 minus x sub 1, quantity squared. Subtract the y's, y sub 2 minus y sub 1, quantity squared, and then we take the square root. Now we might want to label here. Let's call this x1, y1, and x2, y2. Or, like we did with the midpoint, circle the x's. Okay, so we're going to subtract the x's. So 4 minus a minus 3, so I'm going to put plus 3, and minus 3 minus 2. So that would give us 7 squared plus negative 5 squared. Whoops, this did not get erased earlier. Let me fix that. And that gives us 49. Now here's what you need to understand, folks. This whole quantity is being squared. And so whatever this answer is squared, and so it's always going to be a positive. And then we have 474, the square root of 74 for an answer, which that doesn't give us maybe a real good idea of what the answer is. So let's just put that in the square root to see what the approximate answer is. It is about 8.6. The square root of 74 is about, I should put a little squiggly mark, approximately 8.6. And so that would be the length of the segment. And let's just kind of count. So this is about 1, 2, 3, 4, 5, 6, 7. Yeah, it's 8.6 sounds about right. Alrighty, let's look at the next problem. Here it says, your friend calculates the distance between the points 1, 5, and 3, 8. What is his error? So if we'll recall, this is subtracting the x's, x sub 2 minus x sub 1. And then here we're supposed to be subtracting the y's. So the x's are 1 and 3. Oh, that's not what they did. They subtracted one of the y's right there. And then the y's are 5 and 8. So they mixed up an x and a y. So let's do that the right way. So we're going to subtract the x's, 3 minus 1. And then we're going to subtract the y's, 8 minus 5. So we started here. We took 3 minus 1. And then when we get to the y's, let's start at the same place. It'll be 8 minus 5, and that's quantity squared. So 3 minus 1 is 2. 2 squared is 4. 8 minus 5 is 3. 3 squared is 9. And that gives us the square root of 13, which is approximately 3 something. Let's see. 13, and hit the square root button, 3.6. All right, and we'll just do a couple more here, and these are actually off of your homework problems. So it says find the distance between the pair of points. So the distance formula is x sub 2 minus x sub 1, quantity squared, and y sub 2 minus y sub 1, quantity squared. So let's just circle the x's so we don't get those mixed up. So we have 2 minus 2, so 2 minus 2, and then we'll go to 5 minus a minus 1. So 2 negatives make a positive. So 2 minus 2, it's 0. 0 squared is still 0, so let's just cross that out. And then we have 5 plus 1, which is 6. And that's squared, which is the square root of 36, which just equals 6. So the length of that segment is 6 units. All right, last one. So the distance formula, x2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. All right, so we're subtracting the x's, so minus 8 minus 10 quantity squared. And then 14 minus 14, another one that we'll be able to just cross out. So 14 minus 14 is 0, and when you square 0, you get 0. Now, these are both negative, so I'm going to keep the parentheses there, so that's negative 18 quantity squared, which is 300, the square root of 324. A positive, negative 18 squared is 324, and the square root of 324 is just a positive 18. All right, so then you can work on your assignments and let me know if you need help. Make sure you're checking your answers as you go. Thanks.